We'll see you again tomorrow. You'll come here again tomorrow. Make sure you grab the handouts on your way in.
Oh, yes. My mom was not very happy about that.
Do you ever get the okay. Oh yeah, I did. You know it. Yeah. Usually, yeah. Do you need help doing that? I don't know if he's supposed to. Ready? Are you gonna be good?
Wait, I'm still treasurer, right?
I don't know. But I know it's like no, but okay. Geology, we already have all of it. Yeah, it's gonna be awesome. And it's like you can sit in your chair. Yes. We're gonna have rock stars and like people who like email them like email in
Get out a couple things. Number 3 and number 4, I'm going to talk about, and I need you to have it out to know what I'm referring to. So, bell work up on the board tells you what you should be doing.
I've been sorry to get my
I did exactly. Yeah. So I just did that. Do I need anything else?
Brady.
I think I'll do it after school.
You can do that too.
Is that not blocked?
I would ask
One recommend. Yeah. I'll have to check it out. It's so boring. Bro, I played it all the time. I was just playing. The German one?
Okay, John. You can actually scoot one more over. Sit at 24, not 25. Okay, we need to get started here. Good to see you all. So we need to kind of clean up a little bit from day 1. And so again, that's why I asked you to get out a couple of those assignments. The 2 handouts you guys picked up today, I did not get a chance to number those before I made those copies, so your bell work is to number those 2. Number 7 is the one that says something about intermediate value theorem. So please put a number 7 on the top right of it. I was hoping that we could at least start it today, but it looks like we won't have time to. So my second period is also in Cal AB class, and they didn't have time to get to it, so you probably won't either. But I wanted you to have it. The other one that you picked up is number 5. And so what we'll do on that today is we'll talk about how to deal with 0 over 0 in ways other than factoring. We talked about factoring last class, and we'll practice a little bit more of that today. But you need to see some of the other algebra approaches with that.
Which of these two is number 5?
My right, your left hand. There you go. Yep. Sorry, that's why I try to number them sometimes for you. 6 will be on your own paper.
Okay.
If you're not sure, I'll say it again as we get to them. You just have to be looking. Okay, so on assignment number 3, I told you I was going to take that up, and I am going to take that up. But first, especially on the last page, I know that you may have a question or two. So there's a lot of times where we'll do assignments and I will have solution links on the website for any of them that you need help with, and in times like that I won't take time out to do questions in class because I have the other way to help you. And of course with advisory, once you have movement, you can come by and get help if there's something that you struggle with a little bit more. But that was not the case for neither one of those were the case for this assignment. So was there any, specifically on the back page first, was there any of these that you found to be harder than the others? Any of these you'd like me to go over with you? Number 3. Okay. So that's what I was hoping you would ask. Now, I actually made this video and recorded it last class because they wanted to go over it. So it is on the website now, but you didn't know that. It wasn't there last time I saw you guys. Okay, so all 4 of these questions are past AP questions, like real AP level questions. And on one hand, They're a little bit easier because you just thought about this stuff. And also, at the end of the year, once you have a lot more calculus under your belt, you know, trying to remember how did I do this the first couple weeks of school is also a little bit of a challenge. But question 3, the AP exam does change a little bit over the years. So this one, greatest integer function, I have not seen them ever ask this question besides this. So if I was you, I wouldn't worry about memorizing what the greatest integer function looks like. That being said, I do want us to go ahead and talk about it real quick because you guys are all very math-minded, and this is a good one for you to see. So this thing called the greatest integer function is just the case where you always want to round down. So if you have any number between 0 and 1, you round all the way down to 0. If you have a number between 1 and 2, you round all the way down to 1. If you have a number between 2 and 3, it rounds down to 2. Goes the other way also. Any number between -1 and 0 rounds down to -1. Any number between -1 and -2 rounds down to -2. So you may have overheard me because I did tell a few people this last class if they were working a little bit quicker. This is sometimes referred to as the step function because it looks like steps. So I don't know, this used to be more important, but again, if you don't remember this, don't stress out and study it. I just think that it's good for you to at least see it. Okay, so to answer the question though, what's the limit as x approaches 0 from the left of 2 over the greatest integer of x? So looking at this graph, what is the limit as x approaches 0 from the left? It approaches -1. Very good. So your answer comes from 2 over -1 or -2. That's the answer they want you to get. So really, if you know that function, you can see that it's a fair question. But now, unfortunately, there are some things that get thrown at you. Today in second period, a unit circle question came up, and that person may not have realized you have to know the unit circle. So I will review you on it here and there, but if you've never learned the unit circle, there's stuff like that that does carry over. Then there's stuff like this that sometimes doesn't carry over. So I will try to always at least let you know what you're on the hook for. Okay, was there any follow-up to this question? Everybody okay with what it was wanting you to do once you saw the graph? Okay, is there another question on the back page? Okay. Was there one of the others that you found to be harder than the rest? Something that you think we could all benefit by going over quickly?
Number 8.
Number 8? Okay. Now again, to me, you're really balancing two things here. You're trying to work with limits for one of the first times, and 2, you're trying to learn some of this notation. What does all of these symbols mean? What are they telling you to do? So in part A, I had a lot of questions about this one, but this one's really just combining 2 clues into one. This is referring to a point when x is -2, y is 1. So for your graph to be correct, that point has to be there. And they're telling you the limit as x approaches 3 needs to equal 1. Both of these things equal 1. So as it approaches 3 from the left, it gets closer to 1, and as it approaches 3 from the right, it approaches 1. Now, I was helping somebody with this yesterday, and they said something like, how do you know this is going down and not up? Well, truthfully, I don't know. I'm just doing what it says. I've got the point. This one's got the right limit. So just pick one. Okay, h of 3 is undefined. What does that mean as far as the graph goes? Okay, so if it's not a point, what's it going to be? Right, so make sure you put a big open circle there so there's no doubt about that. When x is 3, there is no y value. Okay, the limit as x approaches -2 from the left needs to be less than the limit as x approaches -2 from the right. So I can come back and fix this later if I need to, but I'm just going to go ahead and connect these. So from the right, it looks like I have a limit of 1. and I need that to be bigger than the limit from the left. So I can't connect these because then the limits would be equal. So as long as the limit from the left goes somewhere less than y equals 1, shouldn't be a problem. So now, why is it important that I do an open circle on this?
Because it wouldn't pass the vertical line test.
Okay, how did you know it wasn't supposed to pass the vertical line test?
Function.
Very good. As soon as it says function, that implies your answer better pass the vertical line test. If it hits here, it can't hit here. That's how that one has to be an open circle. Okay. Then it says h is supposed to be constant from -2 to 3. So constant just means flat. It's not increasing, it's not decreasing. So again, I had guessed this, and I was wrong, but I can fix it. Now it's constant there, and decreasing everywhere else. Okay, I've got one last mistake in here. What do I not have correct yet? Yeah, go ahead.
The line going on the bottom left is increasing, not decreasing.
Right, notice this is going up, and this said decreasing everywhere else. So this needs to be going down. This one needs to be going down. So you could have a slightly different looking graph and still be correct, but you've got to have this point like I still do. This limit has to be going to that like I still do. This point can't exist like I've got. The limit from the left needs to be less than the limit from the right. That's still correct. This part needs to be constant, which is true. Needs to be decreasing everywhere else. That is true. If all of this is true, then your graph is fine, even if it looks different than mine, even if it looks different than your neighbor. Okay, was there one of these specifically that y'all thought were harder, or just getting used to it? You okay with that? Okay. All right, so please make sure your name is on this, and this one's just a participation grade. So I will do about a 15-second scan. If I see that you're missing something, it will be half credit, but remember, you can finish it, give it to me before the test completed, and you can get half of those points back. If it looks like you did it all, then you'll get full credit. Now, if you forgot to do your homework, I would still go ahead and turn it in. You'll get half credit, but then at least when you finish it, you'll get half of the points back. If you just don't turn it in because you don't have it finished, then you can turn it in for late credit, but the max you could get is half. So even if you don't have it finished, you can get the maximum number of points by at least letting me have what you have today. So normally I would have you turn this in at the beginning of class, but since I wanted to give you a chance to ask a few questions from it, that's why I didn't have you do that. So make sure your name is on the paper, and then if y'all would just pass them towards this side of the room, and I'll collect them all at once. I should be able to grade these and get them back to you today. I don't want to keep any of these papers because these will be resources for you, not just for our next quiz, but for the AP exam also. Okay, is that everybody's? Okay, so next up, let's see what the agenda says. Next up, we need to review and finish number 4. So number 4 was one we looked at last class, and I had you think about it, but I didn't ask you to do any of it. This is what number 4 looked like, although you should have numbered it. So for the review, I want to talk about the ones we did together last time very quickly, just 30-second review. Then I'll work 2 questions for you on the next page as a reminder, and then I'm going to give you 10-15 minutes to try a chunk of these questions. So, unlike assignment 3, what was different about this one was we didn't have the tables. We had the functions instead. So, first step is you should always try direct substitution. Just plug this number in. If you end up with a number, circle it as your answer. Try to plug this number in. We had nowhere to plug this in, so 6 stayed our answer. But if you try direct substitution and you get 0 over 0, that's when it gets more complicated, and that's where we need calculus. This isn't really calculus other than knowing what limit stands for. So on this handout, we're only worried about the factoring technique. So if you get 0 over 0, you try to factor the numerator, factor the denominator, factor the numerator, factor the denominator, get something to cancel, x divided by x, x plus 7 divided by x plus 7, and then after something cancels, you do direct substitution. I plugged in 0 into what's left over. I plugged negative 7 into what's left over. That's how we will be able to deal with all of the questions on this one. Try direct substitution. If you get an answer, great. If you get 0 over 0, try to factor, cancel, and then do direct substitution. Okay, I think I'd mentioned that the special limits, you don't have to worry about those. We crossed those off last time. Is that correct? Okay. Again, it's not that you don't need to know how to do them. It's just that there's a better way to do it once you know a little bit more calculus. So I don't want you to do it in the least efficient way. Okay, so on the next page, and I know there's some of you that worked ahead, and that's great. I never will discourage you from that because it just keeps making the next class a little bit easier for you compared to everybody else. But I'd like to do one of each of these for you, just as another reminder, and then I'll give you some time to try some yourself. So here's my function. I don't know what this graph looks like, so if I want to know the limit, I'm going to do direct substitution and hope I don't get 0 over 0. Because if I get something else, I'm done. Sometimes limit questions take that long, about 5-10 seconds. You just have to know to start with direct substitution. Okay, if you go all the way down to question 9, this is one that my last class asked about. This one looks a little bit more intimidating, so let's go ahead and use this as a second example. Okay, so you should start off with direct substitution, but I totally understand why you might not feel comfortable without a calculator. 2 times negative 7 cubed plus 11 times negative 7 squared minus 21 times negative 7. Who in the world knows what that's going to be? But I could go ahead and just factor, and I'm going to show you why this makes the arithmetic easier. I'm trying to avoid using a calculator here because 99% of the time this is going to be a no calculator question. If this was a calculator question, honestly, I would probably just do this. It would be faster. I would graph this in my calculator, I would look at the graph, and I would do what we did in last class. I would just see what it approaches from the left and the right of negative 7. So assuming we have no calculator, the bottom's a GCF, the top has a GCF, and even after the GCF, it's got a trinomial. So factoring accuracy is definitely more important than speed. Please slow yourself down if need be. I'd rather you take a minute to factor it and get it right than to do it quickly and miss it. Now, I still don't know if this is 0 over 0, but I'm just trying to give you a strategy to deal with these big numbers like this. Now, do you see if I plug this in, why does the numerator go to 0? Because what? Okay, right here, right? When you plug in negative 7 here, does everybody see this goes to 0? And 0 times, who cares what that is? 0 times anything is going to be 0. And then same thing in the denominator. If I plug in negative 7 here, negative 7 times anything is going to be 0. So Unfortunately, it's 0 over 0. I say unfortunate because that means I've got to do more work. But until we get to the next handout, the only thing you need to worry about is factoring. And I've already got it factored. Get something to cancel, and then try direct substitution a second time. Plug in -7 everywhere there is an x. And then do the arithmetic. -14 minus 3 should be -17, I believe. But that doesn't sound familiar, so I'm going to double check my work real fast, just in case. No, that's fine. So, this is the I want to emphasize the calculus versus the algebra. The calculus, it helps if you know what a limit is, but you don't even really have to know what a limit is to be able to do these questions. You have to understand the process. Direct substitution, you get an answer, quit. 0 over 0, try to factor, cancel out, and then do direct substitution. That's the calculus that you're learning. The algebra is where you're going to put in the time and the effort and what can be challenging. Sometimes it's hard factoring, GCF and trinomials. Sometimes it's just GCF. But you're going to see, I don't know, 90% of the time you think calculus is hard, it's usually the algebra steps like this. Being able to do 4 or 5 or 6 algebra steps without a mistake. Not usually the calculus that you're having to learn behind it. So, not that that makes it easier, but that's what it is. Okay, there's a couple of questions here that you won't have to do, so let's go ahead and mark those off. They have to do with these types that I told you not to worry about last time, the special trig limits. So, no calculus that you know right now is going to let you do question 5 or 6. Just put a big X on those so you don't accidentally spend a bunch of time on those. X through 5 and 6. And then on the back page, '25 and 27 are no-goes right now. The other 2 you should be able to do. So go ahead and put an X by those also. Obviously, when I take this up for points, I'm not going to expect you to have those done, because I'm telling you that you don't have to worry about
Is
that.
19 and 20 also crossed off?
Oh no, 19 and 20 are good questions.
They're good?
Yep, they're good. 19 and 20 are unit circle questions. So, but 23 is a no-go though. So let's go ahead and just talk about 19, because that was one last class asked, and I saw a few surprise faces here. So I'm not trying to call you out, but did you skip pre-cal?
Yeah, in 10th grade though. I'm a senior now, so it's been a bit.
Okay, so you never took pre-cal.
No, I did take pre-cal.
Oh, you did take
Yes,
pre-cal.
I
Okay,
did.
okay. Well, for those of you that skip pre-cal, this is one of the biggest hurdles early in the year, other than just the rigor of questions. Because in pre-cal, at least first semester, we do unit circle to death. We talk about the unit circle and memorize it in about week 2, and then we use it all semester long. But just as a quick example, so you know what a unit circle question looks like, number 19 is one of these. The process is the same. Try direct substitution. Is this 0 over 0? No, so it's not a factoring, or I'm sorry, it's not indeterminate form. That means your answer comes from this. You're almost done. But you have to know the unit circle. You have to know the radians around the unit circle so that you know where pi is. Calculus, we don't do anything in degrees. Higher mathematics is radians only. What is the point at pi radians? Okay, so you have to memorize all the points around the unit circle so that you can say something like the cosine of that point is what? Good. Cosine's the x value, sine's the y value. You can take sine divided by cosine if you need tangent, and you can flip sine to get cosecant, you can flip cosine to get secant, and you can flip tangent to get cotangent. So, if you don't know that, if you've never had a class where you had to learn the unit circle, that is something that you're behind on from everybody else. So, might as well just do one more like this. Now notice, that's a quick and easy question with the asterisk if you know the unit circle. So this one, if we do direct substitution, we're going to get the, need to write the limit, not be lazy. 4 times pi over 8, what does that reduce to? Okay, pi over 2. I guess I did plug it in. Where is pi over 2 on the unit circle? Very top. What's the point at pi over 2? 0, 1. Which one of those is your sign answer? 1. So if you have the unit circle memorized, again, those are 2 of the easier questions on here. But if you don't have the unit circle memorized, that's something you need to prioritize. We use that quite a bit, even at the beginning of the year.
Wait, is that our answer? Are we done now?
That's it. Direct substitution is all I did. I plugged it in, evaluated. Plugged it in, evaluated. You only have to do more work if you get 0 over 0.
Gotcha. All right.
It's just that this evaluating is harder because it's unit circle. It's not just arithmetic. Okay, so I am going to shut up here for a few minutes so that you can practice some of these. This is one of the 2 things I will ask you to give to me next class. With no school on Monday this week, that means tomorrow is an A day. So I won't see you again until next Tuesday. But this is one of the 2 things I will ask for. So for right now, I'm going to give you about 10, 15 minutes tops to chip away at this. I'll take a question or 2 if you find one that you found to be harder than the others. I do have the solutions posted on the website if you want to check them as you go over them. But just make sure that you at least check them before you turn it in to me next week. And while you do that, I'm going to try to grade these homework papers so I can get them back to you today. So that's the plan for now. And as long as you can work quietly, you're welcome to work with your neighbors if it helps. Yes, sir.
I was in those. Are these two the same? Like, could I cancel these two out?
Almost. So it's good that you noticed that they're almost the same, but notice this is a positive x, negative 2, and that's a positive x. Yeah, so they're the exact opposite.
Okay.
So if you like factor out a negative, like a GCF, you can switch both the signs and then cancel them.
Oh, okay. Now you flash.
They need to sign out and take the pass there. Again, I'm giving you a few more minutes to work on this, to get some of it done, and then I'll give you a chance to ask a few questions before we move on. But then you'll be on your own to finish it for homework. Not when you need to put your phone up. Johnny.
So, excuse me? Oh. Question, is that a warning or how does that work? Am I in the system now or?
You've been in the system, so. Okay, I'm gonna give you about 5 more minutes before I ask you to move on. But again, I said I'd give you a chance to speak up if you found 1 or 2 of these that you were thinking were harder than others. If there are a couple of these that you would like me to go over with you. Number 17. Okay. Okay, hold on one second. I can only remember one at a time. Okay, if you need help with number 17, go ahead and follow us up on the board here. So I know I'm going to do direct substitution. Hello? Uh-huh. Okay, Angel, you need phase 2, first floor office.
But should I take my stuff?
She said you'd be right back, so. Okay, so I know I need to do direct substitution. I can see the denominator goes to 0, which isn't necessarily a problem, but I have no idea what the numerator goes to. So, to make my life easier, even though sometimes I say don't just factor right away, in this case you probably do need to factor. 5x times x gives you 5x squared. You could do -4 and a -1 to get you +4. And then that foils to be minus 21x. Now I see if I do direct substitution, this is going to go to 0. 0 times anything is 0, and this goes to 0. So, until we look at our next handout, if you get 0 over 0, factor, done. Cancel something out, done. And then try direct substitution again. Plug the 4 into whatever's left over, and you should end up with 19 as an answer. Anybody have something else about 17 before I move it out of the way? Okay, ma'am, what question do you have? 24? Okay, so question 24, this is one of the actual AP questions. This has been asked on an AP question before. So Johnny, you want to tell us what step 1 is?
Yes.
Good. What do you always do first?
It's coming back. Simplify.
Nope. Direct substitution. Okay. So what is the natural log of 1? Okay, what's 0 divided by 3?
Nothing. So it would be 0.
So there's your answer. You need to know, so again, I know y'all are going to hate me saying this the first few weeks, but it's one of the biggest hurdles you have to get over in this class. Stuff like this, they expect you to know this. They expect you to know the natural log of 1 is 0 because e to the 0 gives you 1. They expect you to know the natural log of e is 1 because e to the first gives you e. Some random logarithm stuff like that does show up occasionally. Okay, can I take one more from somebody else? Anybody? Okay, go for it.
We can do 11.
Okay, so with 11, I can see that direct substitution is going to make the denominator go to 0. I can do that in my head, but once again, I have no idea about the numerator. Plugging 1/3 into the numerator probably goes to 0, but I just don't know. So short of getting a calculator out, because this would probably be no calculator, I'm going to factor it, and then I should be able to see. In fact, I can kind of cheat. What do you think this is probably going to be? It's probably a -1, because you know that you're probably going to cancel these, right? So if this is a -1, what would this have to be? Right, and then check with FOIL. 15x minus 2x is 13x, so that worked out. Okay, so now I can see plugging in 1/3 does make the denominator 0, but it also makes the numerator 0. So factor, done, cancel, done, direct substitution one more time. Plug in the 1/3 into whatever's left over. 2/3 plus 5 is the same thing as 2/3 plus 15/3, which is 17/3. Okay, so what I need y'all to see from this is the bulk of the legwork here is factoring, but that's okay. Factoring is good practice. So if you're not finished with this one, you might want to write on the top, this is one of the 2 things I will ask you to finish up between now and Tuesday. So we need to move on as a group, but okay, so one of the handouts you guys picked up today is number 5, and I need to show you a couple different question types, branching off of what we did last time, and then I need to show you how to deal with 0 over 0 besides factoring. And then I will have you practice one of those things in Khan Academy. So, number 5 is the one that looks like this. Okay, so this one's just notes, so just follow along with me. We're going to discuss all of this one together. You shouldn't have any leftovers from this one. And the first part should be just a review. So, when we want to do a limit of a function like x squared, do direct substitution. If you get a real number, you can assume that's your answer. Try direct substitution. If you get some number other than 0 over 0, last class we said that would have a limit of what? This does actually go to infinity, but what's another way to say infinity? Undefined or does not exist. It's only 0 over 0 that's going to be a problem. So when we try direct substitution on this one, we get 0 over 0. So right now, your only way to deal with that is with factoring, factor, cancel, direct substitution a second time. That's what you were just practicing on the other worksheet. So these 3 questions have summed up everything you know right now about doing limits analytically. Okay. We're going to skip this one because it's just another factoring question, and you guys just practice a handful of those. Okay, this little flowchart, I realize this flowchart's not helpful to a lot of people, but I think it is helpful to some people. This is about summarizing our process here, and it's not nearly as complicated as it looks. So here's the part you've already heard. You start with direct substitution. If you get something like a number over 0, you're going to say that it's undefined. If you get a number, that's going to be your answer. But if you get 0 over 0, that's what we call indeterminate form, and you've got to do more work. The more work could be factoring. But truthfully, it can be any algebra thing that you've ever learned. So one of them we'll look at today is conjugates, and another one we'll look at, but not practice, is trig identities. So sometimes you've got to do that. Once you get something to cancel, whether it's the factoring type of question or the conjugate type of question or the trig identity type of question, once you get something to cancel, you go all the way back up to the start and you do direct substitution the second time. Same thing I've been saying with those other questions. This is just kind of the full process. So if that helps you, then scan it again. If it doesn't help you, then oh well, it didn't hurt you. Okay, so of these questions, I'm sorry, I want to go a little bit out of order here. Some of these are really just doing the same thing we did last class, but with piecewise functions and tables instead of graphs or functions. But the ones I really want to focus on are question like 6. Let's start with 6 and then we'll backtrack and do some of the others. Okay, so right now, what you should have ingrained in your head, one of the very few calculus things I've said is, if you're trying to do the limit of a function and you don't have a graph of the function, you should start with direct substitution. This question is going to give me 0 over 0. You should now know that 0 over 0 requires more work. The next thing that should go through your head is maybe I should factor, because that's all you've seen that works out so far. But notice this numerator doesn't factor, this denominator doesn't factor. So this is not a factoring type of question. We're having to deal with this in a new way. So what I would like to do, the trick to these question types, is I want to take this fraction and I want to multiply it by 1. The reason I want to multiply it by 1 is when you multiply something by 1, you don't change its size. But I want to multiply by a very fancy looking one. And the one I want to multiply by is the conjugate of the part that has a square root. So I'll remind you, conjugate just means the exact same thing, but you switch the middle sign. Not this sign also, just the middle sign. So the conjugate of 1 minus the square root of 3x minus 5 is 1 plus the square root of 3x minus 5. Notice anything divided by itself is 1, and I'm multiplying by 1. So that's how I'm going to make this look different without changing the question and changing the size. So now let's rewrite where we're at. I need to multiply these fractions together now. So numerator times numerator. Just leave it x minus 2 times 1 plus the square root of 3x minus 5. There's no benefit in foiling that. That's numerator times numerator. But the denominators, something special is going to happen. This is the reason conjugates are a thing in mathematics, is because they help us, they just work for some questions. So I'm going to FOIL that over to the side so that you can see how this works out. First part of FOIL, 1 times 1 is 1. The outer part of FOIL would be 1 times the square root of 3x plus 5, minus 5. The inner part of FOIL would be negative square root of 3x minus 5. And then the last, a positive times a negative is going to be negative, put parentheses. Square root of 3x minus 5 times square root of 3x minus 5 would be 3x minus 5. Now, I don't usually write all of this, but the nice thing about conjugates that always happen is the outer and inner part of conjugates should cancel out. And so what's really left behind is a 1 plus 5 and a negative 3x. So it looks pretty scary there for a second when you're going to multiply those two nasty fractions together, but I really didn't even do anything with the numerators except to show they're multiplied. The denominator's foiled, and because you were foiling conjugates, most of it just goes away. Now, I'm still not done. I still have not had anything cancel. You still need something to cancel, just like the factoring questions. But the unique part of this question is finished. This is the part that you might want to give yourself a hint in words, highlight, emphasize. This is what's special about this question. Now, notice the denominator just factors. Something cancels. And then as soon as something cancels, just like the factoring questions, direct substitution will probably finish this off here. Looks like we get negative 2/3. So it's not that you're going to have to do 10 of these on your AP exam or anything. There'll probably be one, and there'll probably be one of these on our first major quiz. The main thing is you just need to know that this is a tool. Direct substitution didn't work, factoring didn't make sense, so then you should consider conjugates. It just needs to be on your radar. And again, what stood out to me about this question that was conjugates is this denominator has two terms and one of them had a square root. So that's typically when you need to use conjugates. So I will ask you to practice this once we finish the other questions. But skip down to, I'm trying to look at the more interesting ones first. The ones that are just an extension of the 0 over 0. If you skip down to 10 and 11, this would just be two other things you need to have on your radar. So number 10 is just going to be a different algebra trick. Calculus isn't changing. In theory, you all remember this algebra, but realistically, most people don't. That's why we're going to take a minute and talk about it. But you can plug in, you would get 3/4 minus 3/4 over 2 minus 2. You get 0 over 0, so you at least 5 seconds of work, you realize this one's going to take some more effort. We've done a handful of factoring questions. Factoring doesn't make sense here. We just talked about a conjugate type question. How do you know that this doesn't have anything to do with conjugates? Right, there's no square root in the question. You really want a square root to deal with conjugates. So we've got to do a different algebra trick, and it's making this look different with algebra. So first off, it's good if you remember that when you have fractions within a fraction, notice these two small fractions within a larger fraction. This is called complex fractions, and you need to know how to deal with complex fractions for a handful of things, but limits just happen to be one of them. So what you really want to do is you want to get rid of these small fractions. So I would love to multiply this by 4 because multiplying by 4, dividing by 4 cancels. But you can't just multiply this by 4 without multiplying every term by 4. Okay. Likewise, I want to get rid of this x squared. So to get rid of a divide x squared, I want to multiply by x squared. Those are inverse operations. But you can't just multiply one term by x squared without multiplying them all by x squared. So really, it looks like I'm doing something fancy, but I just multiplied by everything by 4 to get rid of some small denominators, and then I multiplied everything by x squared to get rid of the rest of the small denominators. And then I'm left with this. So I guess if you had to summarize it in one sentence, I just multiplied every term by all of the small denominators. Now, I'm still not finished with the limit question, but the unique part of this question is done. Multiplying everything by 4, multiplying everything by x squared. It is now in the format that looks like something that could be on the last worksheet. We could factor out a GCF here, maybe switch these terms around. We could factor completely. We have the difference of two squares. Just like the factoring questions, just like the conjugate questions, you need something to cancel, and then as soon as something cancels, you can plug it in and you should be about done. Negative 12 over 16, and that reduces to negative 3/4. But you need to emphasize, highlight, write yourself a note, whatever, what I have highlighted there. How I got that from being a complex fraction to not being a complex fraction. And again, in theory, you all know how to deal with complex fractions, but I know in reality, that's a skill that you forget sometimes. Okay, the last one that should be 100% new to us is number 11. I want to show you one more strategy today. So we're building to our toolbox. We've got direct substitution, we've got direct substitution in factoring, we've got direct substitution in conjugates, we've got direct substitution in complex fractions, and now we're going to have direct substitution and trig identities. So there are a ton of trig identities, but to be fair, calculus only uses a handful of them. Not every trig thing you learned in pre-calc carries over to calculus, but most of it does. So you could probably factor out the 2 out of the denominator. It's got a GCF. But that's all the factoring that can be done. Nothing cancels, so this is not strictly factoring. The next thing I would consider is conjugates, but there's no square roots, so this is not a conjugate type question. The next thing I would consider is complex fractions, but this is not a complex fraction. I don't have small fractions within a big fraction. So I got to figure out some other way to make things cancel. And again, this is what I would call a trig identity question. So eventually, at some point, you're going to have to realize, wait, I can make cosine squared look different. What is cosine squared the equivalent to?
1 minus sine squared.
Very good, 1 minus sine squared. So one of the 3 Pythagorean identities, one of them, the main one, comes up quite a bit in calculus. Sine squared plus cosine squared equals 1. I think you all actually have this on the top of your desk. I think everybody has the same one by your seat number. So I've got all 3 of them listed there, but the top one is pretty common for calculus. Okay, can I cancel these? Are these the same thing? Good. That squared makes a big difference. But the unique part of this question is over. Knowing this is the same as this, this is actually just a difference of 2 squares. I've got 1 being squared on the left, sine being squared on the right, plus and a minus. Just like all the other question types, something cancels, and then direct substitution should work. 3 times 2 over 2 should end up with 3. So, if you skipped pre-cal, and or you forgot that, that's one of the things you need to memorize for these question types. Sine squared x plus cosine squared x always equals 1 for any value of x. And then you can manipulate that to substitute as needed. Okay, so let's go and do some of the less interesting questions. To me, those are the more important ones here. But I want to go ahead and go over the rest of it with you. So question 12, if I just did direct substitution here, I would get this. What would your answer to this be after direct substitution? Okay, does not exist. 4 divided by 0 is undefined. Not every limit question takes a bunch of work. Going backwards now, question 9. That's a limit question. Try to do direct substitution. If you get an answer, double check that for me, please. You get an answer, circle it, move on. It's only 0 over 0 where we have to dig deeper. Okay, number 8, direct substitution, 0 over 0. Which one of our techniques do you think is probably going to be needed for this one? Good, probably factoring. In fact, if I covered this up and didn't let you see it, that should have still been your guess because factoring is the most common way. GCF in the top, difference of 2 squares in the bottom. Something needs to cancel so that direct substitution can work. If you can factor, you can do these question types. Okay, for the last questions, I do want you to actually think about some of these before I just do them all for you. And this is not different than what we did last class, except it's in piecewise format. So I'm still going to be doing the same calculus, but it's not given to you as a function. Well, this is a function, but it's not given to you as a graph. It's not given to you as a table. It's written in a different way. So the reminder I need to give you here is that the limit to this, in your head, you need to think about what is the limit as x approaches -1 from the left. You need to think about what's the limit as x approaches -1 from the right. And if these are the same, just like we looked at visually last class, if these are the same, that's the answer to this question. Now with a piecewise function, you have to put some thought into which one of these pieces it gets plugged into. So if I want to know as x approaches -1 from the left, which one of these two has numbers to the left of -1? Good. This is describing numbers left of -1. So you would plug -1 into this and get -1. What about if I want to know from the right of -1? Which one of these two is describing numbers to the right of -1? This case is the bottom, so you're going to plug -1 in here, and you're going to get 1 minus 2. And if the limit from the left equals the limit from the right, that is your answer. Now, the mistake that some of you are going to fall into is you're going to say, oh, okay, he just plugged this in here, plugged this in here, they were the same, so that's his answer. It depends. You really need to think about what that piecewise function is telling you to know which one to plug it into. So, one last example of this, and then I want you to try the others. Go all the way up to number 2 so you can see what I'm saying. You should not plug -5 into both of those function parts. The limit as x approaches -5 from the left and the right really should get plugged into the same piece of the piecewise function. So that's what these restrictions are telling you. So is it the top restriction or the bottom restriction that's going to help me with numbers around -5? Just the top, right? 0 to 10 is nowhere near -5. So in this question, the bottom piece is the actual distractor. You would actually plug in -5 for the left limit, and you're going to plug in -5 in for the right limit. But if you plug the same thing into the same thing, then you're going to get the same thing. So sine of -5 pi, what would that be from the unit circle? Okay, but I just want the sine value.
0.
Just 0. Very good. -5 pi is 2, 3, 4. Right here. Sine's the y value. So don't just fall into the habit of saying, I need to plug it into both. It might be that you only plug it into one. You have to think about which one of these restrictions makes sense to plug into. It's not that formulaic. Okay, if you would try the other questions on here, I'll give you a few minutes. And then I'll share my answers with you and we can talk about the ones we need to talk about.
The bathroom pass still see her name on the board.
Yes.
Okay.
I put it over here though.
Oh, okay.
Last year I did phones or names on the board, and this year, since y'all can't have phones up,
Just do names.
I just do names. So I put it over there to have more space over here.
Because this is for the lefties.
Okay, number 2? Yeah. That's what I got. They were both different, but they were really off by 1, so.
Well, yeah, but like 3 of them. Yeah.
Okay, sounds like y'all are getting close, so let me give you just a moment. Oh, there was only a couple. I'm sorry. I thought there was more. I thought I left more for you. Okay, so in a second, I'm going to tell you the other thing that I want you to do at the end of class here today that might end up being a little bit of homework. I've got 2 Khan Academy assignments for you. One of the Khan Academy assignments is going to be like this question type, where you're doing a limit from a table. And again, to me, that's 99% the same thing we did last class. It's just a table is a different way to give the same information as a graph. So, for the limit to exist, that's not ever going to change. Mentally, you need to be thinking about what is the limit as x approaches -2 from the left, which would be numbers slightly less than -2. Mentally, you need to think about what is x, the limit as x approaches -2 from the right, which is where you would take a number bigger than -2 and then head towards the left towards -2. Okay, so what y value does it look like it's approaching from the left? What y value is it getting closer to?
0 to I.
Y value, not x value. 9.04, 8.23, 8.20. It's probably getting close to 8. Okay, from the right, 8.97, 8.15, 8.03. What do you think that's approaching? 8. Now again, we don't know 100% sure. That's why it says reasonable estimate. But if your limit, if it's approaching 8 from the left of -2 and 8 from the right of -2, then your limit, your answer to that question should be 8. Same exact stuff, same exact calculus. It just, you know, you got to process the information slightly different. But so one of your Khan Academies will be over that. So you'll have to get 4 in a row of those correctly, but that one should probably be pretty quick. The other Khan Academy I'm going to have you do is one of these conjugate type questions. So you can practice these like number 6. Okay, but for your other answers to check real quick. Sorry, I did forget this. Did this print off well enough for y'all to see this, that this was 3 from the left? The left did print off okay? No, it didn't? Okay. That's fine. If you worked it just from the left, your answer would be 8. But if you didn't see that, I'll just do it both ways. You would need to plug it in up here to see the limit from the left is 8. And you need to plug it in here to see that the limit is 7. Not the same, so does not exist. Number 4, I'm guessing you didn't see this little plus here. That didn't print off great. Okay. So if you did see the plus, your answer would be 1 over 16. If you didn't see the plus, you should have plugged it into this one for the right limit. 2 to the negative 4th is 1/16. Are y'all okay with where I'm getting at? Anyone want me to say why? Okay. And you would need to plug it in here for the left limit because of this, which would be negative 1/3, I guess. Is that what you got? Okay. Not the same. So if you didn't see that plus, you should say does not exist. Okay. And then I think last one, as x approaches negative 3, you need this one for the left limit and you need this one for the right limit. So plug it in here to get 2. Plug it in here to get 4. Limit from the left doesn't equal the limit from the right, so the limit does not exist. Whether you're talking about graphs, tables, piecewise functions, whatever, the limit from the left has to be the limit from the right. Okay, are we okay with that? Okay, so next up, you do need a piece of your own paper to do your scratch work. You don't have to write the questions down or anything, but I like you to do this on scratch work in case I need to see your scratch work. And that way, if you need to give yourself any hints or make any notes, you've got a place in your binder where that goes. So, blank piece of paper, numbered is number 6. I've got extra paper over here if you need to come borrow some. Numbered is number 6. If you have your Chromebook, you can go ahead and get it out and start on it. There's only 2 Khan Academy assignments. We won't get to number 7 until next class, so you can do either one of those you want. Limits from the table or dealing with 0 over 0 in the conjugates. There's a good chance you want to keep out your notes so that you can use that one as an example. Now, while you do that, I need to tell you that I do have you do quite a bit of Khan Academy at the start of the year. We don't use it very much at the end of the year, but I like it because it tries to give you the correct amount of practice. And what I mean by that is, when you guys do the table one in a minute, a lot of you are just going to get the first 4 questions right. And so that means you know what you're doing. I don't want you to do a worksheet of 20 of them if you know what you're doing and 4 is enough to show me that. But if it hasn't clicked for you yet and you need to do 20 of them, then Khan Academy is good for that. Because if you miss one, start over and try it again. You can redo it as many times as you need to get 100%. And if you need the practice, you need the practice. So the other thing I like is if you miss a question, in the bottom right, it'll say like, try again, but also it will link get help. If you click that get help, it shows you all the steps to get that answer. And so you can compare your work to their work, you can learn from your mistake, and then hopefully you don't make that mistake again. And you can click restart so that you can start over on question 1. So, and you get different questions. So I do want you to stick with those long enough to make 100 on both of them. The only 2 homework things I'm going to give to you today is I want you to make 100 on both those Khan Academy assignments, number 6, and I would like you to make sure number 4 is finished and ready to turn in. Both of those things are listed under homework. So if you're not listening to me, you didn't catch that, whatever, just glance at the agenda this weekend. It shows in the bottom left. Make sure you have number 4 finished and ready to turn in, and have hundreds on number 6. Any questions about the homework? Sorry, so I only got you about 15 minutes, so y'all can work on that if you have your Chromebook. If you didn't bring your Chromebook, then you just have to do a few more minutes outside. But the only other thing I have for you, finish up, go ahead. To finish up from first day of class, we do have a new student today, John. So we did introductions on the first day, so if you'll stand up. You need to tell us about yourself.
I'm John. I play tennis here. That's good, right?
Well, what else did we ask? Favorite dessert, I think?
Yeah.
Oh, I like ice cream. And
Okay.
chocolate chips, my favorite.
Favorite restaurant in Fayetteville?
Favorite restaurant?
Yeah.
Smitty's.
Yeah, there you go.
Yeah.
Yeah. What else did we ask everybody first day?
Furniture, favorite.
Oh, favorite furniture. Yeah, we did that.
Furniture? I don't know. Just like a couch, probably.
Okay,
Sorry.
you're good. We didn't do introductions on the first day. I'm just messing with you.
Yeah.
Oh, that's a job. Yeah, I actually dropped it.
Favorite furniture.
Yes, I
Okay. Yeah, so if it's OpenDuck in Google Classroom, which I think it should be, you're welcome to take a picture. Otherwise, you can give me a hard copy when you come back. The problem with that is I don't think to ask you, so if you don't remember, then it becomes late. So it's easier if you just do Google Classroom. I don't have the handouts for Tuesday yet, unfortunately, but I will put them on the website, and then of course the class recording will go over everything. So if you watch that, you will see it.
John, I was out of English for a while, and I just lost my contact for the first time, and it's only showing like 6th grade courses. I don't know why. Like, was it assigned? Did you assign it? Yeah. I promise, but maybe not. It's only 67% that's wrong. I'm just unsure. Thought at AUG.
See if I see you on the list there. Did everybody else get into Khan Academy okay? I think it was giving me issues with my other classes, but I think it auto-enrolled you guys. I thought it did. Was it Brady?
Brady 5, yes.
Did you get signed up for the Google Classroom last
Yes,
class?
I'm in the Google Classroom right now.
Check your email.
Okay.
I think I sent you a link, and if you click that link, it should add you to the class.
Thank you.
I was just gonna ask you that for me too. 'Cause I'm not. I just signed in the Google Classroom. I'm not in the contact.
Okay, I emailed you a link. Try that. That worked? Okay. Anybody else trouble getting into Khan Academy? Now again, Khan Academy does a pretty decent job, I think, of helping you see your mistake if you click the get help when you miss one. But if you do have a question, just raise your hand as I come around and I'll help out. Yeah, just the very, like, this is a term and this is a term, so just switch the middle between the two. You got one right?
Yeah, I'll just button it up.
I'm trying to learn some of your names, but I'm looking at your pictures, and some of your pictures are old, so. Wasn't the best idea. Guess I just need to call some out. So Gabby. Brody? Brady, okay, that just looked like I one.
Yeah,
So
I'm sorry.
No, it's fine.
Horrible name already.
If I learn your name wrong, it'll take me.
Mr. Townsend, I was still gonna turn work in. Remember last year you had us take a picture of it and upload it on Google Classroom?
So my plan is to still give you that option. The problem is you're not allowed to get your phone out to take a picture. I've heard from other teachers that it's not that bad to take a picture with your Chromebook, but that sounds weird to me, so
Okay.
I don't know. Yes, you'll still be able to take pictures of your work with your phone when you're at home, or I guess you could do it at lunch if you wanted to.
Or would you rather us just turn it in to you?
The hard copies is fine too. I don't have a preference.
Okay.
I just also don't have sympathy when you forget it.
I got you.
So, because I would just assume you turned it in early. Denny? Sarah? I think it says Brendan.
That's me.
Which one is it? Brendan? Yes, sir. Okay, thank you. Allie? Derek? Sorry. Mark? Are you related to Ian? No. still got a couple more papers to pass out, so bear with me here. You guys got about 5 minutes, so let me recap. You got to need 2 things done before next Tuesday. Number 4 needs to be finished and completed, ready to turn in. And number 6, you should have 100 on both of these Khan Academy assignments. You're welcome to keep going up until the bell, which again is about 5 minutes from now. But I've also got a puzzle to share with you, so if you like puzzles, this gives you something to think about. The first part of the question, well, the second part of the question is pretty tough, but the first part, you might have to shut up. I just randomly found this on YouTube a couple days ago, and apparently it's been used as an interview question for like Google, Microsoft, Amazon, Goldman Sachs, lots of them use it for interview questions. Austin. So if you want to finish that.
I'll call you up and then you have my Google.
I want to say Joe or your Thomas. Pierce and Bill. Do you think the answer is 24? No, that's guessing. Okay, well, what do you think the answer is? Anybody got a guess?
Hold on, I want to be
I'll tell you what. If you're interested in this and you want to know the answer, I'll put a video in the Google Classroom. If you don't care, it's fine. It doesn't have anything to do with calculus, it's just for fun.